About 2 million years ago, an ancestor of yours woke up on the sun-baked African savanna, stretched, and looked out across the horizon. There was no refrigerator to open, no coffee pot brewing on the counter, and certainly no stove to turn on. They simply plucked raw leaves, chewed tough roots, or scavenged whatever raw meat was left behind by larger predators. Fast forward to this very moment, and someone in a modern kitchen is standing over a simmering pot of broth, carefully adjusting the heat and tasting for salt. We spend billions of dollars on kitchen gadgets, study recipe books thicker than brick blocks, and turn food preparation into an international art form. Cooking is so deeply embedded in human culture that we celebrate milestones with banquets, seal deals over lunch, and gather our families around dinner tables every single night. We have built entire legal codes around food safety, sanitary standards, and restaurant inspections. So why did this start? Where did it begin, and why us? When virtually every other creature on Earth gets along just fine without ever touching a flame. A jaguar tears into raw flesh without a second thought. A blue whale swallows tons of raw krill in a single gulp. A chimpanzee, capable of learning sign language and solving complex puzzles, has never once looked at a cold piece of yam and thought about caramelizing it over an open flame. No one can point to the exact Tuesday morning when the first piece of meat fell into a fire, and no one ever will. But the trail of biological evidence that brings us close runs through something much stranger than a kitchen appliance. It leaves its mark directly inside our teeth, our intestines, and the massive weight of our brains. That realization gets more fascinating the deeper you look into it, because the story of cooking is not just the story of dinner, it is the story of how a weak, hairless ape turned an environmental hazard into the engine of human intelligence. Before we look at the first hearth, we need to appreciate a bigger biological mystery. Why our bodies look so completely different from every other primate walking the planet. Here is something people rarely stop to notice about our physical design. Chimpanzees have massive jaw muscles and broad molars capable of crushing raw vegetation for 6 hours a day. Gorillas possess enormous rib cages housing vast digestive tracts built to ferment tough plant cellulose. We, on the other hand, stand in the middle of the primate lineup with tiny mouths, weak jaws, and delicate teeth. We look like creatures that gave up on raw nature and threw away our built-in food processors. Even our closest living relatives spend nearly half their waking lives chewing raw, fibrous materials. Something about the specific path our ancestors took made shrinking our gut and jaws entirely worthwhile. The leading scientific explanation comes down to energy efficiency and thermal processing. Raw food is notoriously difficult to digest, requiring immense muscular effort and long hours of internal fermentation. Eating raw meat or raw tubers forces the digestive system to expend a massive portion of the body's daily caloric energy just breaking down cell walls. So across hundreds of thousands of years, our ancestors stumbled upon an external stomach, fire. When heat hits organic matter, it performs the exact same chemical work that digestive enzymes do, but outside the body. Heat denatures tough proteins, softens dense starches, and breaks down complex molecular bonds. It turns tough, dangerous roots into soft, easily absorbed calories in a matter of minutes. The human body carries a shortened digestive tract that would fail miserably if forced to live on raw wilderness foliage today. We are, without exaggeration, biologically addicted to processed heat. Exposing food to fire did not just change what was on the menu. It rewired our entire metabolic strategy around a body that no longer needed a massive gut. Wonderful for saving energy, but considerably less wonderful if you forget how to make fire and find yourself stranded in the wild. Which means the real breakthrough was never just about tasting better. Here is the conventional version of the discovery of cooking. An early human found a burnt animal after a savanna wildfire, took a bite, loved the flavor, and decided to roast everything from that day forward. Simple, clean, and poetic. Except controlled fire usage requires foresight, patience, and social cooperation that takes long evolutionary time to build. Archaeological evidence points to controlled fire use appearing anywhere between 400,000 and 1.5 million years ago. The anatomical shift in hominid teeth and brain size pops up even earlier, around the time of Homo erectus. So if cooking was just an accidental snack after a wildfire, why did our anatomy transform so drastically across such a massive stretch of time? That gap suggests fire was not an occasional trick, but a habitual survival technology. Something social and cultural held that fire burning long before anyone knew what a kitchen was. Normally, a breakthrough like this would leave clear traces everywhere. But ash washes away in rainstorms. Charcoal turns to dust. Unburnt bones decay in acidic soil over millennia. Whatever the very first cooking pit looked like, it crumbled back into the earth long ago, which is exactly why evolutionary anthropologists had to look directly at the human genome and skull fossils instead. And this is where evolutionary biology becomes a detective story. In the late 20th century, primatologist Richard Wrangham proposed a radical idea known as the cooking hypothesis. His research argued that cooking was not a late luxury invented by modern humans, but the catalyst that created us in the first place. Here is the metabolic math you actually need to understand. The human brain is an energy vampire. It accounts for roughly 2% of our total body weight, yet consumes over 20% of our daily energy expenditure. In a world of raw food, you simply cannot harvest enough calories in a day to fuel both a huge brain and a huge digestive tract. Nature enforces a strict metabolic budget on every creature on the planet. A gorilla cannot grow a human-sized brain because its massive gut demands every calorie it can chew during 12 hours of constant foraging. By outsourcing the work of digestion to fire, early hominids broke that biological ceiling. Shorter guts freed up massive reserves of metabolic energy. That newly freed energy was funneled directly into expanding the cerebral cortex. We literally traded our large intestines for larger brains. The moment our ancestors started cooking, they set off an evolutionary chain reaction that reshaped the skull from the inside out. Jaws shrank, facial muscles softened, and brain cases expanded to hold billions of new neural connections. Fire did the heavy mechanical work, freeing our ancestors to think, plan, and socialize. An evolutionary trade-off so profound, it transformed a humble savanna ape into a creature that builds telescopes and writes symphonies. Strangely beautiful and slightly mind-bending, depending on how you look at a hot meal. Probably both. So what did the very first cooked meal actually look like? It was certainly not an elaborate multi-course dish served on ceramic plates. It was likely a dirty starched tuber pushed into hot coals or a piece of tough antelope hide charred over embers. Unseasoned, blackened, and covered in grey ash. Yet that simple burnt root offered 3 times the accessible calories of its raw counterpart. That efficiency created free time, an extraordinary novelty in the animal kingdom. Animals in the wild are locked in a relentless cycle of hunting, chewing, and digesting. A chimpanzee chews continuously for hours just to survive the day. A human can consume a day's worth of cooked calories in less than 30 minutes. That left early humans with hours of empty afternoon daylight. Hours that could be spent crafting sharper stone tools, inspecting surroundings, or teaching children how to track animals. Cooking gave us something far more valuable than nutrition. It gave us spare time, which leads us to the second major theory behind the campfire: social bonding and language development. Raw food eating is an individual, solitary activity. Watch a troop of baboons feed, and you will see each individual grabbing raw plants and guarding their pile from rivals. Fire completely changed that dynamic. A campfire is a stationary light source in a dark and dangerous night. You cannot carry a blazing fire around while chasing a gazelle. You must build it in a safe place, stay near it, and guard it together. Food had to be brought back to the hearth, shared and monitored while it slowly cooked over coals. Gathering around a central fire forced early humans to sit face to face in close quarters for extended periods. In the pitch black of the prehistoric night, the circle of firelight became a sanctuary from prowling saber-toothed cats and cave hyenas. Safe inside that warm ring of light, waiting for meat to roast, humans had nothing to do but look at one another. They began making eye contact, interpreting subtle facial expressions, and vocalizing thoughts. The campfire became the world's very first classroom, theater, and council chamber. Gestures turned into sounds, and primitive grunts slowly organized into structured language. Elders recounted past hunts, warnings were passed down to children, and shared myths began to take root in collective memory. The hearth created culture long before cities or farms ever existed. We did not just sit by the fire to eat, we sat by the fire to belong. The leap from tossing a root into ash to actively controlling temperature was another massive cognitive step. Welcome to the world's first culinary technology industry. Run by small bands of early humans learning which wood burns longest. For hundreds of thousands of years, cooking remained basic and direct. Meat on a stick, tubers in the embers, seeds toasted on flat stones, primitive, smoky, and unpredictable. Then, around 20,000 years ago, archaeological records show another dramatic leap. Researchers begin finding scorched clay fragments and fire-cracked stones in ancient hearths. Not just pit fires, but deliberate boiling stones heated in fire and dropped into water-filled animal hides or wooden troughs. That meant stewing, simmering, and rendering fat with extreme precision. One of the oldest known pottery fragments was discovered in Shanrandong Cave in China, dating back nearly 20,000 years. Someone shaped river clay, fired it into a sturdy vessel, and used it to boil soups and grain porridge. That was engineering design born from a deep understanding of thermodynamics. Experimental archaeologists have tested boiling food in stone-heated vessels against direct open-flame roasting. The difference in nutrient retention and safety is astonishingly large. Boiling breaks down tough connective tissues in old animal bones, releasing marrow fat and collagen that would otherwise be wasted. It turns bitter, toxic seeds into soft, digestible meals that can feed infants and elderly group members who have lost their teeth. The cooking pot was not just a container, it was a life support system for the vulnerable. It allowed human tribes to care for their grandparents and raise healthier infants through soft weaning foods. And it arrived just when the planet faced brutal environmental swings during the last glacial maximum. It turns out cooking was also our greatest shield against microscopic enemies. Raw meat and decaying scavenged carcasses are breeding grounds for lethal parasites and bacteria. Pathogens like E. coli, salmonella, and tapeworms pose constant deadly risks to raw food carnivores in the wild. Fire acts as a sterile chemical cleanser, neutralizing toxins and killing microscopic parasites before they reach the stomach. Early humans who cooked their meat suffered far fewer parasitic infections and lethal food poisoning outbreaks than those who ate raw kill. Natural selection quietly favored the cooks over the purists across every single generation. The hearth was an ancient laboratory where heat served as the ultimate antibiotic. Here is the part that still separates human cooking from anything else in nature. If cooking were purely about survival, every human group would have settled on the single simplest way to prepare calories and stop there. That is not remotely what happened across history. Instead, humans transformed cooking into identity, status, and art almost immediately. Spices were traded across vast deserts and dangerous oceans for prices higher than their weight in gold. Kings built massive banquet halls to display power through exotic dishes no ordinary farmer could afford. Religious traditions created complex dietary rules, distinguishing sacred foods from forbidden ones. Ancient Egyptian tombs were packed with miniature bakeries, wine jars, and preserved meats to feed souls in the afterlife. Look at any modern wedding, holiday feast, or family gathering today, and that ancient pattern still shines through. We still break bread together to seal friendships. We still prepare special family recipes passed down through 3 generations of grandmothers. None of that is about pure calorie intake. It never was. We use flavor as a language of love, memory, and cultural pride. No other animal seasons its food or takes pride in a perfectly baked loaf of bread. That ritual is uniquely ours. Even as agriculture transformed society 10,000 years ago, cooking remained the cornerstone of human settlement. Wheat and rice are virtually inedible to humans in their raw states. Without fire and water to boil grains into bread and rice, the agricultural revolution could never have launched. Cities could not have formed, empires could not have risen, and modern civilization would never have taken root. We built our entire global infrastructure on top of cooked grass seeds. Think about the chemical reaction that occurs every time bread crust turns golden brown or a steak gets a crispy brown sear. Scientists call it the Maillard reaction. It is a complex chemical interaction between amino acids and reducing sugars under high heat. It produces hundreds of new flavor compounds that do not exist in raw ingredients. Our brains evolved to react to those specific aromas with intense pleasure because they signal rich, safe, easily digestible calories. The smell of roasting food triggers salivation deep within our nervous system before we even take a bite. That sensory delight is millions of years of evolutionary reinforcement whispering in your ear. We did not just learn to cook because we had to. We learned to love the smell of fire. Eventually, stone hearths gave way to brick ovens, cast iron stoves, and modern induction cooktops. People began fermenting grapes into fine wine, aging milk into rich cheeses, and distilling aromatic herbs into spices. A technology that began as a crude survival trick in a dusty cave grew into a global industry worth trillions of dollars. But that multi-billion-dollar culinary world is really just a sophisticated evolution of the same original instinct. Gathering around a warm fire, softening nature's rough edges, and making food safe to share. So why did ancient humans actually start cooking their food? The honest answer is that biology, climate, and social evolution collided all at once. It likely began as accidental thermal processing, an easy way to make tough wild roots easier to chew. It became a biological imperative almost immediately afterward, shrinking our guts and fueling our exploding brains. It became a social anchor once tribes gathered around nighttime fires to share warmth and build community. And it eventually became our cultural fingerprint as human societies grew more complex than any simple recipe could capture. The remarkable part is not just that we started cooking. Given everything we know about our species, deeply social, endlessly creative, and metabolically demanding, it was probably inevitable from the start. You are living proof of that long evolutionary chain right now. Whatever you ate for lunch today, a series of complex culinary choices was made to transform raw ingredients into your meal. Someone harvested, washed, heated, seasoned, and served that food specifically for human consumption. Think about how much of your daily routine already runs on this same ancient instinct. Deciding where to go for dinner with friends is not just a random errand, it is the same ancient software making a social calculation about bonding over shared warmth and flavor. Meeting someone for coffee or sharing a pizza on a Friday night carries the exact same emotional resonance as sitting around a hearth 200,000 years ago. You are doing precisely what those ash-covered figures were doing beside a cave fire in Pleistocene Africa, working out how to share resources, nurture relationships, and feel safe in a chaotic world. Over 1 million years of uninterrupted human behavior connects directly to the hot meal sitting on your kitchen table tonight. That is not a minor historical detail. That might genuinely be the entire story of who we are. We got hungry, we found fire, we got smart, and then we spent the next 1,000,000 years arguing over who makes the best barbecue. Some things really do not change across the eons. From wild savanna embers to Michelin-starred dining, fire has been our constant companion. It protected us from darkness when we were small and vulnerable. It shaped the bones of our faces and the structure of our thoughts. It allowed us to conquer freezing ice ages and cross barren continents. Every time you strike a match or turn on a burner, you are igniting the tool that made us human. Without cooking, our large brains would wither under the burden of raw foraging. Without cooking, our languages might never have found the quiet hours needed to grow into poetry. Without cooking, our families would not have a central anchor to return to at the end of a long day. It is the silent engine operating behind every human culture on Earth. No matter how advanced our technology becomes, we never outgrow the warmth of a shared meal. We may fly spaceships to Mars and build artificial intelligence, but our bodies remain wired for cooked food. Our teeth are still small, our stomachs are still short, and our brains are still hungry for hot calories. We are the ape that tamed fire and turned dining into a sacred art. A species defined not by the strength of its jaws, but by the creativity of its hearth. Next time you smell garlic sizzling in olive oil or bread baking in an oven, pause for just a moment. Listen to the quiet chemical symphony happening inside the pan. That sizzle is the sound of human evolution continuing its long, delicious journey. It is a reminder that we survived against impossible odds because we learned to cooperate around a flame. In a universe filled with cold stone and dark voids, we built tiny pockets of light and warm soup. And in doing so, we cooked our way into becoming the dominant mind on Earth. 1,000,000 years of culinary innovation packed into a single bite. So here is a quiet thought to carry into your next meal. When you sit down to eat tonight, you are not just fueling a body. You are participating in the oldest continuous ritual in human history. A ritual born in smoke, tested by ice, and refined by thousands of generations of cooks. Take a moment to appreciate the fire that made it all possible. And maybe thank whoever took the time to cook for you today. So, an honest question for you. Could you survive on a strictly raw diet like our wild ancestors, or is a hot meal something you could never give up? What is the one cooked dish that instantly feels like home to you? Let me know down in the comments below. If you enjoyed this deep dive into human origin stories, consider hitting that like button and subscribing to the channel. It helps us keep bringing you these deep biological and historical explorations every week. Share this video with someone you love sharing a good meal with. Until next time, stay curious, eat well, and take care of each other. I will catch you in the very next video. Take care.